Welcome to the Professional Machine Learning Engineer Crash Exam course. Today we will focus on Anthropic foundational models, focusing on architecting reason-based alignment, agentic autonomy, and mechanistic interpretability. This Claude architecture includes components like the constitutional AI gateway, agentic autonomy controller, and neural network debugger. Deconstructing the frontier ecosystem reveals it as an integrated software environment. It comprises the glass box for interpretability, edge interfaces for protocol, the engine room for compute and context, and core logic and alignment for constitutional AI and reason-based scaling. Examining generational capability scaling, we move from the baseline Claude 2 to the frontier architecture of Claude 4.6. This progression shows improvements in alignment, context handling, and interaction, notably introducing agent teams and native computer use. Traditional reinforcement learning from human feedback, or RLHF, faces systemic bottlenecks. These include fragmented reward signals, compounded latency due to scaling issues, and epistemological vulnerability, or sycophancy, where models try to please human raters. Constitutional AI projects values by replacing human bottlenecks with an explicit, reason-based constitution. This process involves a supervised critique and revision phase, followed by RLAIF, or reinforcement learning from AI feedback, which replaces human raters entirely. The Constitution defines a prioritization hierarchy. The highest priority is broadly safe, followed by broadly ethical, which includes honesty. Priority 3 is compliant, related to specific directives. The lowest priority is genuinely helpful, which is optimized only when the first three are met. The Claude 4.6 deployment triad illustrates a trade-off between reasoning capacity and cost. Haiku 4.5 offers fast inference. Sonnet 4.6 supports multi-agent workflow orchestration. Opus 4.6 provides maximum capacity for complex oversight and strategic planning. System 2 reasoning is achieved via adaptive thinking, replacing legacy extended thinking. The model autonomously evaluates request complexity and dynamically scales reasoning depth before generating an output. This is managed using the /effort parameter API. Infinite memory is enabled via context compaction. This feature addresses the exhaustion of large token limits by persistent agents. The Context Compaction API is a server-side protocol that compresses conversation history into a compaction block. Agentic bifurcation separates functionality into Claude Code for developers and Claude Cowork for knowledge workers. Claude Code uses a terminal-based CLI for deep system operations. Claude Cowork provides a secure, desktop-based GUI for automation without coding. Multi-modal fusion and the zoom action allow Claude to process text, code, and UI screenshots. This maps code variables to visual elements, pinpointing layout mismatches. The Computer Use API introduces the zoom action for handling high-resolution visual inputs. The contextual retrieval architecture eliminates retrieval failures in domain-specific corpora. It combines dense vector clustering via vector embeddings with sparse keyword retrieval using BM25 keyword filtering in a pipeline fusion process. The Model Context Protocol, MCP ecosystem, is a universal standard using JSON RPC 2.0. It allows for automatic discovery of server methods and schemas upon connection, and for chaining multiple MCP servers in a single prompt for complex workflows. Opening the black box involves sparse autoencoders, or SAEs, which are Anthropic's mechanism for decompiling dense neural activations into readable feature vectors. This enables real-world mapping to specific neural circuits responsible for concepts. Scaling interpretability is achieved through the stream algorithm. The breakthrough is a hierarchical pruning of 97% to 99% of irrelevant token interactions. This results in near-linear time complexity, allowing developers to trace model decisions across large contexts. Feature steering and behavioral vaccination are key safety measures. Persona vectors monitor the model's mood for trajectory drifts toward toxicity. Behavioral vaccination intentionally doses the model with toxicity data during fine-tuning to build natural resilience. Auditing and securing agentic workflows mitigate threats like prompt injection and tool poisoning. MCP Safety Scanner acts as an AI penetration tester, hammering exposed endpoints with adversarial requests to catch schema violations before deployment. The AI Safety Levels (ASL) framework operationalizes safety. ASL2 is the baseline, models with dangerous theoretical knowledge but lacking practical autonomy. ASL3, the Opus 4 trigger, is the critical threshold when models demonstrate advanced proficiency with CBRN threats. ASL3 defenses in production include constitutional classifiers at the software level. At the infrastructure level, weight security mandates two-party authorization and strict egress bandwidth controls throttle network traffic to mitigate multi-gigabyte weight exfiltration. Synthesis is the continuous alignment engine, a closed-loop discipline. Constitutional AI guides adaptive thinking, which is safely exposed via the Model Context Protocol, while being continuously mathematically audited by sparse autoencoders. This concludes the video on the Neural Blueprint Stack, detailing the architecture and safety features of the Anthropic foundational models.